Welcome back. In this session, we are going to see linked list. Linked list is a very important concept in data structures or in computer science. So the topic is linked list. We have seen different data structures in C++. There are simple data structures as well as compound data structures. Based on different criteria, data structures are classified. We have structures. We have array. These are termed as simple data structures. We have seen compound data structures, stack, queue, that we have already learned. And in that category, we have seen linked list. Again, these compound data structures are classified, as we all know, linear data structure and non-linear data structure. Under non-linear data structure, we have graphs and trees. Under linear data structure, we have stack, queue, and the third one is this linked list. See, apart from this stack and queue, this linked list is a dynamic data structure. Linked list is a dynamic data structure. What does it mean? What is the difference between a static data structure and dynamic data structure? Data structures which are implemented using arrays or data structure whose size is already determined. It has a limitation in accommodating or inserting new data items. Its size is predetermined in the case of static data structure. Here in the case of dynamic data structure, it can grow as long as RAM is available or free space in RAM is available. So its size is not predetermined. So this linked list, the first point about linked list is a dynamic data structure. And as the name implies, linked list, it is a linked list of memory blocks. Why it is called linked list? Because it is a linked list of memory blocks. These memory blocks, we call this memory block as a node, or we can say it is a list of nodes. It is a list of nodes, equal sized memory blocks that consume equal number of bytes. We name it as nodes. So linked list is a list of nodes that are linked. Now, what is a node? A node is a self-referential structure. A node is a self-referential structure. A node has two parts. A node has two parts. When you look into the structure of this node, you can see two parts. One part is the data part, and second part is the link. Link part data part stores data associated with node, and link part stores address of next node. About this linked list, address of the starting node, address of the first node is stored in a special pointer named start or header. Then link part of last node will be null. It points nothing to indicate no more items after that node. So this is the brief introduction about linked list. So a linked list is a list of linked nodes. A node is a memory block. That memory block has two parts. First part is the data part and second part is the link part. The link part stores address of next node, and the address of first node is stored in a special pointer called start or header. This concept is pictorially represented in this way. So a node, as we said, it has two parts. Here is the data, here the link. Let this be the first node. The address, the base address of this node is stored in start. So this points this. And the link part of a node contains the address of next node. So we represent it like this. So we can, if you reach here, we can access this node. Why? Because we have the address here in this node. Again, this is data, this is link. Address of next node is here. Again we have address of next node here. It continues, and in order to indicate the end node, last node here, this contains null. So this is the pictorial representation of a linked list. Now our question is, we have seen that the node is a self-referential structure. What is a self-referential structure? A structure having a pointer of the same structure inside that structure is a self-referential structure. A structure with an element as an element of the same structure. I mean that contain a pointer variable which is of the same structure. Let us see. We can define a node, a simple node like this. Struct. Usually we name it as node. As we know, a node contains two parts. First part is for the data part and the second part for the link part. Now, suppose we are storing an integer number in a memory block, or it can be a name. So let it be a name. So we can write char name of 20. So the data part is a character array that can store a name having a maximum of 20 characters. Now the second part, the link part, it is of the structures type, that is node star link. This link is a pointer of this type node. Node is the structure itself. So this is a self-referential structure that can be used as a node. Now suppose we are storing register number, name and sex of student. Such a node can be created. Struct, say node. If you want, you can stud node. So here we have int regno char name of 20, then gender. So this makes the data part, and then stud node star link. So this makes another node. So here this is the data part. In this case, all these make the data part. So this is the definition for a structure that can be used as a node in a linked list. Now the next question is, what are the operations that can be performed on linked list? All the operations that we have seen, that insertion of new elements, deletion of an element from the data structure or the linked list, sorting, searching, merging, all the traversal, all these operations can be performed on a linked list. Now, how will you create a linked list? The first thing that we have to learn is how to create a linked list. We have seen the structure. The first node is, the address of first node is there in the start pointer or head pointer. Then we have to create a new node. We have to link that node with the end node of existing linked list, and that is to be continued. So what would be the steps for creating a linked list? First one, create a node and get its base address. Second one, insert data into the node and assign link part with null. Third step, if it is the first node, then store the address of node in start pointer. If it is not the first node, store the address in the link part of last node. Repeat the steps 1 to 4 until creation is over. So this is the steps for, or this is the algorithm for creating a linked list. Create a node and get its base address. Insert the data into the node and assign link part with null. If it is the first node, then store the address of node in start pointer. If it is not the first node, store the address in the link part of the last node. Repeat the steps 1 to 4 until creation is over. Let us see with the with the help of an example. So the first step is to create the node. See, we have, say, a definition like this: struct node int data node star link. So this is our definition for the node. And we know linked list is a dynamic data structure. We are going to allocate memory in dynamic fashion. So create the node which is to be added with the linked list. So what we do, say node star x equal to new node. So this will be the statement to create a node. This will allocate memory. Say, let this be the memory allocated. It has two parts, the data part and link part. Here it can store the address, here it can store the data. Now the next step is insert the data and assign the link part with null. So the data to be inserted into the node, let it be 100. Right? Now we assign this null here. So that's the second step. Now the third step is, if this is the first node, we are creating a linked list. If this is the first node, what we have to do is assign the address of this to start. So we have a node called, a pointer called start here. So what we have to do is, you have to make a statement like this, start equal to x, because x is another pointer, x contains the address of this. So this will be something like this. Here we have x, let this the address of this be 1000, so this contains 1000. Now we have start here, right? Start another pointer here. We made a statement like this, start equal to x. So what happens, this 1000 will be copied to this one. So here it contains 1000, which means this points this. Now, no doubt x also point this in the first step. Now this continues. The steps 1 to 4 will be continued. If it is not the first node, suppose we are going to create another node, the same procedure, node x star x equal to new node. What happens? Another block of memory will be reserved from memory. Right? Now, assign values. Let this be 47 and we make this as null. So if it is not the first node, what is the thing that we have to do? Store address. Here this will automatically change. Here x content of x will be, let this be 1500. What happens here? 1500 inside this. So this will be something like this. X contain, the newly created node will contain, x will contain the address of newly allocated memory, base address of newly allocated memory. So 1500 here. Right? Now the point is, if it is not the first node, what we have to do is, it is to be, the address is to be stored in the last node of the linked list. So last node of linked list is, now it is the start itself. So what we have to make is, we have to keep a pointer with this and make a statement to say we have traced this with another pointer called y. This y contains 1000, let this be also. So what we have to do is link this. So we can write a statement like this, y dot link equal to say this x. So y dot link is this one. This will be stored with 1500. So here comes 1500. This points this. So in this way we can create linked list. We shall see the C++ code for the creation of linked list in another session. So this is the basics of linked list. The remaining will be discussed in the next sessions.